Okay, to wrap up section 1.3 on trig functions, we're going to look at something called quadrantal angles. It's a weird word. The quadrantal angles are just the angles that are right on the xy axes. So for instance, we're going to deal with 0 degrees, we're going to deal with 90 degrees, work with 180 and 270. We could throw 360 in there, but it's kind of redundant because 0 and 360 are coterminal angles. Okay. So we'll deal with these four. Now your textbook is going to have some of these trig functions, actually all of them, listed out for all four of these quadrantal angles. Okay. So a couple things to keep in mind. Remember how to find the trig functions you had to draw a triangle, and then you look at the x, y, and r coordinates of that triangle. Well, here, if we're looking for the angle to be 0 or 90 or so forth, then we're actually looking for the point to be on those axes. So for instance, if I wanted to find all of the trig functions for 90-degree angle, well, 90-degree angle has a very specific value for one of these three letters, right? We got x, y, and r. Well, on 90 degrees, your x is 0, right? You have to shrink x down to 0, and then you have a y value that goes up. So this is going to be the point 0 comma y, because there's definitely a 0 in the x coordinate, and the y value is positive. Okay. And so when I put those into the functions, what's interesting is that a couple of them become 0. A couple of those values become 0. All the x's do. So the cosine then at 90, if theta is 90, the cosine is 0, because you get 0 over r. Okay. The tangent is undefined because you get y over 0. 0 is the x, right? So you put a 0 under in the bottom of a fraction, you get an undefined value. Let's get rid of 180. Okay. The cotangent will be 0 because the 0 will go on top. And the secant will be undefined because the 0 goes on the bottom. Okay. Alright, so that takes care of all of the x's being 0. But we also know one other thing, that at that point, the y value and the radius are the same. The vertical side of the triangle, it's kind of not really even a triangle, because it's shrunk down to where the thickness is nothing. But the r and the y are the same distance. It's interesting, the vertical leg of the triangle and the hypotenuse would kind of overlap exactly, okay? And so when r and y are the same thing and you divide them, anything divided by itself is 1. And so if they have the same value, then you get a 1 there. Same thing for the cosecant. The cosecant is r over y. Again, you get the same thing on top and the same thing on the bottom. And so that's going to become a 1 also when you cancel them. And so that gives us all 6 of our trig values for a 90-degree angle. All right, so this works as long as we're dealing with a 90-degree angle. So this is for theta equaling 90 degrees. That's what we just determined. And you could go through the same logic for 180 and 270 and 0. Basically, you figure out which variable is 0 and which two variables are the same. In this previous example of 90, the y and the r were the same, and the x was 0. And then you just plug in where they go, and you can determine the value for the trig function on those quadrantal angles. There is also a table in your book on page 27 in 1.3 that summarizes all 4 of these angles with all 6 of the trig functions. So if you need to check on that, the table on page 27 will have a final summary of all that stuff.